Okay, here's another example of graphing expanded polynomials by factoring, and these are always much easier because we don't have to do the synthetic division. Although we may be asked to write all the possible rational roots. So if we look at this, first of all, we can see that this is going to be, end behavior model will be its positive odd, so it's just going to be like y equals x, all positive odd. Polynomials behave like y equals x, lower left, upper right. The y-intercept when x is 0, y is 45, so there's my x-intercept. And my possible rational forgot to write this down, rational roots, or zeros, are just going to be factors of 45 over factors of 1, so that's just going to be factors of 45, so that's not too bad. So that's just going to be plus or minus 1, plus or minus 2 doesn't go in there, 3, plus or minus 5 goes into 45. 6 doesn't go in there, 7, 8, 9, plus or minus 9. 10 doesn't go in there, 11, 12, 15, plus or minus 15. And I guess plus or minus 45. All right. And if we were going to do synthetic division, we would start with plus or minus 1, negative 1, 3, etc. But let's look at this, and the reality is it looks like we could do, by factor, it looks like we could do 4-term grouping. Because how many times does 9 go into 45? 5 times. So I see this 5 and this 5. That gives me a good idea that I'm going to be able to do 4-term grouping. So let's try that. So I'll group it down the middle. And what can I factor out of those first 2 terms? Well, it looks like I can take out an x squared, right? So we'll factor out an x squared. And what's left in the first term? X. Second term, 5, so x minus 5. Okay, and then what can I factor out of these 2 terms? Well, we always take out, when we're doing 4-term grouping, this leading sign, so it's going to be a negative, and 9 goes into both those, so I'm going to factor out a negative 9. And if I take a negative 9 out of that, I just have x. And if I take a negative out of positive, I have a negative, and 9 goes into 45 5 times. And now I can factor out this x minus 5. And what's left is x squared minus 9. Except this is a difference of perfect squares. So I can factor this again. What's the square root of x squared? X. What's the square root of 9? 3. So that's just going to factor to be the product of the sum and difference of these little numbers. So I've got x minus 5. And then I've got the sum and difference of these little numbers. So I've got x plus 3 times x minus 3. And there's my f of x in factored form. So I've already got it in factored form. What are my zeros? My zeros are x equals 5, negative 3, and positive 3. So those are my zeros. So there we go. All right, so we're going to mark these on our graph, and my intercept was positive 45. So I made a graph here, and these are, I changed the scale a little bit so I could get it on there. So this is 15, 30, 45. So there's my intercept. And negative 3, positive 3, and positive 5 are my zeros. Okay? And we know our behavior is going to be lower left, our end behavior, positive odd, so it's going to be lower left. Starts at lower left and ends upper right. So it just matches this little line here, this diagonal line. And we know that my high point will be somewhere in between these two numbers, right, almost right in between, so it looks like I've got this. So I'll start over here. I'll go up like this, go all the way up to the 45, come back down, and then I'm going to go somewhere in between here, so I can go like maybe around the 4 will be the low point, come back up. And that's kind of, from the data we've got, that's probably a pretty decent representation of my graph. This is more parabolic than circular, so sorry about that. I made a little more semicircle. Awful tempting because of the symmetry. So make it more parabolic and less circular. More like a parabola rather than a semicircle. Yeah. Like I said, this is why you do it in pencil. Don't try to graph in ink, otherwise you kind of have to sketch it around and then shade it in a little bit. Kind of make it conform to the experiences we've had with parabolas, and I think that's pretty good by now, okay? So always do your graphing in pencil. There's nothing wrong with that. You can put your zeros in red. Those aren't going to change, but you may have to refine your graph. So that's what we got. So that was nice. Nice and easy. I think you can see it all right there in one frame. Okay? So this should be straightforward. I hope this helps.